Hello and welcome to my channel. I am Mensah Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and not yet subscribed, please kindly subscribe to us to build the mathematics community. In this session, I'm going to prove using the principle of mathematical induction. So join me as we go through this simple proof. Remember to like, subscribe, share, and leave your comments. Using the principle of mathematical induction, prove that 1 divided by 1 times 2 times 3 plus 1 divided by 2 times 3 times 4 plus 3 plus 1 divided by 3 times 4 times 5 plus plus 1 divided by n times n plus 1 times n plus 2 is equal to n times n plus 3 all divided by 4 times n plus 1 times n plus 2 for all n subset of natural numbers. Yeah. Now, using the principle of mathematical induction, we let the given statement be Pn. So this is the given statement, so we let it be Pn. Now, we show that the base case is true. So that's the base case. That is, assuming that n is equal to 1, we show that P1 is true. So P1 is equal to, you put 1 for where you see n. So let's see. We have, or we can put it here, and it will give us a simple term, and we get it. 1, that is for n, 1 for n. So here, 1 times 1 plus 3 divided by 4 times 1 plus 1 times 1 plus 2. So we have 4, 2, 3 if we put n equal to 1. So here 4 will cancel 4 and you will be left with 1. So here we have 1 divided by 1 times 2 times 3. And that is what we have here as the base case. So P1 is true. Very simple as that. Here 4 divided by 4. 4 cancel SF1, 4 cancel SF1. So we have 1 here. And here too, we have 1 here. 1 times 1 is 1. That is why I didn't bring this one. We want to make this by this one. Okay. Now, we move to the inductive hypothesis step. That is, assuming that PK is also true. So we sum from 1 divided by 1 times 2 times 3 plus 1 divided by 2 times 3 times 4 plus 1 divided by 3 times 4 times 5 up to K. So if we do that, we put K in place of N. So you have 1 divided by K times K plus 1 times K plus 2 equal to K times K plus 3 all divided by 4 times K plus 1 times K plus 2. That is our PK. Now, we are going to prove that PK plus 1 is also true, assuming that PK is true. So here we do the sum up to K plus 1. So here whenever you see n, you put there K plus 1. So this n, K plus 1, this n, K plus 1, and we still have 1 here. And this n, K plus 1, and we have 2 there. Wow. Now look at something here. You see that the whole of this expression is PK, and it is equal to this. So in place of this, you write PK plus 1 equals K, I'm expanding, K times K, K squared, K times 3 is 3K, divided by 4 times K is 4K. Okay, let me take my time. Let me put it down first. Maybe some factorization will help us. So let's write K times K plus 3 all divided by 4 times K plus 1 times K plus 2. Yeah, for PK plus 1 divided by K plus 1 times K plus 2. That is 1 plus 1 times K plus 3. That is 1 plus 2. And here we can factorize K plus 1 times K plus 2 out. So we will be left with 1 divided by K plus 1 times K plus 2 times k times k plus 3 all divided by 4 plus 1 divided by k plus 3. Wow. Yes. Anytime you should look for simple ways to do the factorization. That is why I stopped expanding. Okay, so let's move on. Here we have 1 divided by k plus 1 times k plus 2 times, here the LCM is 4 times k plus 3. So here 4 will come and cancel 4 and you multiply this one by this. We have k times k plus 3 times k plus 3 plus k plus 3 will cancel k plus 3, then multiply here by 4 as 4. Now this gives us 1 divided by k plus 1 times k plus 2 times k into k squared plus 6k plus 9. So let's multiply the k there again to give me k cube and then 9k, so that it will save time, plus 4 all divided by 4 times k plus 3. Okay, this one will save time. That is, expand this. This is k plus 3 times k plus 3, so it's k plus 3 all squared, k squared, 2 times k times 3, 3 squared. You multiply this one by k, you get k cube. Multiply this one by k, you get 6k squared. You multiply this one by k, you get 9k, and you have plus 4 here. So now we can expand to get k cube plus 6k squared plus 9k plus 4 all divided by 4 times k plus 1 times k plus 2 times k plus 3. Wow. Now, where are we moving towards? Or what do we want to prove? Now, look at this part very carefully. You see that when we assume that pk is true, at the end of the day, our final answer, whenever you see n, you see that it was replaced by k. So if we want to prove that pk plus 1 is also 2, then it means that in our final answer, wherever we see n, it should be k plus 1, k plus 1, k plus 1. So here it means that our final answer should be of this form: k plus 1 for this n times k plus 1 for this n plus 3, all divided by, I'm putting here, 4 times k plus 1 for this n plus 1 times k plus 1 for this n plus 2. That should be our final answer. Let me put this one here: k plus 1 into k plus 1 plus 3. Okay. It implies that this should be our final answer. So let's see. Have you got that? Yes, I think we have. Because this one can be written as k plus 1 plus 2. This one can be written as k plus 1 plus 2. And this k plus 2 can also be written as k plus 1 plus 1. So we've gotten this and that here. It means that this k plus 1, you don't need it. It should go. And you have the 4 also there. Okay. Now how do we simplify the top to get what we have here? Very simple. So let's see what we are going to do. At the top, we have k cube plus 6k squared plus 9k plus 4. So we can use, it's a cubic polynomial, so we can use long division method to factorize this, or we can just do some simple technique. And let's see what we are going to do. Look at this. We have a constant term here, 4, and we have k cube here. Wow. So what do we do? Can we factorize k out here? If we factorize k out here, the top one, we will get k times k squared plus 6k plus 9 plus 4. And this is a quadratic equation which factorizes. So we have k times k squared plus 3k plus 3k plus 9 plus 4. And we get back to this, and we can't do anything. Have you seen? So let's see what we can do. What we can do is what we are going to do now. So let's do it. We will not use the long division method. So we have pk plus 1 to be equal to k cube plus 6k squared plus 9k plus 4, all divided by 4 times k plus 1 times k plus 2 times k plus 3. Okay. So let's look at our final answer. Our final answer, we need k plus 1 at the top. So it implies that at the top we should put there k plus 1. Now if we put k plus 1 at the top, what happens? Concentrate on this k cube and the constant term, because here if I multiply this, look at this, k plus 1 by k squared. So concentrate on this. Let's take that. We are concentrating on k cube plus the 4, right? And then what we are going to do is that since I need k plus 1 out, I will just reduce this k cube to k squared, right? Correct. And this constant term, let it be there. So I'm going to multiply this so that you see something. K times k squared will give me k cube. 1 times this will give me plus k squared. K times 4 will give me plus 4k. 1 times 4 will give me 4. Okay, now let's see. We see that if I factorize k plus 1 out and then multiply it by k squared, I'll get the k cube here. If I multiply 1 by the 4, I'll get the 4 here. And you see that the 2 terms will also give me k squared and plus 4k. So this is the trick. Here I have 6k squared. I've gotten k squared, so it has left with 1. 5k squared. So I have k cube plus k squared plus 5k squared. Here I have 9k and I've gotten 4k. So I'll just add plus 4k plus 5k plus the 4. And you see that I've just expanded this to get k cube, k squared plus 5k squared, 6k squared. 4k plus 5k, 9k plus the 4. That is the trick that I've always been using. So you can also use that trick to help you. Remember that we concentrated on only this one and that one and reduce this to k squared, since we are multiplying through by k to give us kk. So let's see if it will help us. So we place this one here. But remember, I have multiplied through this one by k plus 1. So there is no need writing k plus 1 here again. That is it. So take a very good note of that. So the top now becomes k cube plus k squared plus 5k squared plus 4k plus 5k plus 4. Yes. That is it. Very simple as that. So, what can we do here? Can we group and then do some factorization? Yes. Let's see. We have k cube plus k squared plus 4k. Or, okay, let's use the 5k. Here, let's use the 5k squared. And here we have k squared plus 5k plus 4. Okay, this makes sense. Because here, if we factorize k out, you get this. So that we can get two common terms. So here we have k cube plus 5k squared plus 4k plus k squared plus 5k plus 4. All divided by 4 times k plus 1 times k plus 2 plus, times k plus 3. And this one will give me k times k squared plus 5k plus 4 plus 1 times k plus 5k plus 4. All divided by 4 times k plus 1 times k plus 2 times k plus 3. And this gives k plus 1 times, I'm factorizing k squared plus 5k plus 4 out. K squared plus 5k plus 4 all divided by 4 times k plus 1 times k plus 2 times k plus 3. And you see that this k plus 1 has cancelled this k plus 1 out. Are we going to get the k plus 1 here again? No problem. Let's see. We have k squared plus 5k plus 4 all divided by 4 times the down one. We have k plus 1 times k plus 1 plus 2. So I think for the down one, we've gotten it. It has left with the top. And here the top is a quadratic equation which factorizes. So we can factorize it or we can still use intuition. But let us move with that. Let's factorize. This gives us k squared plus k plus 4k plus 4. That is, multiply 4 by 1, you get 4. And the factors of 4 that will sum up to 5 is 1 and 4. So we have all this by 4 times k plus 1 times k plus 1 plus 2. We are almost done. So this gives us k times k plus 1 plus 4 times k plus 1 all divided by 4 times k plus 1 times k plus 1 plus 2. And here, if we factorize k plus 1 out, we have k plus 4 times k plus 1, all divided by 4 times k plus 1 plus 1 times k plus 1 plus 2. And this gives k plus 1 times k plus 1 plus 3, all divided by 4 times k plus 1 plus 1 times k plus 1 plus 2, as we have here. So you see that in our final answer, we have k plus 1 representing n, k plus 1 representing n, k plus 1 representing n, k plus 1 representing n. So since pk is true, pk plus 1 is also true for all n subset of natural numbers. Thank you for watching. Please kindly subscribe, like, share, and leave your comments.